Alright, in this video we'll be covering the integral of cotangent cube of x. So if you want to solve this problem on your own, pause the video here. Alright, so now when solving this integral, I'm going to first think of it as cotangent x times cotangent squared of x. We now need to consider the Pythagorean identity, which is sine squared x plus cosine squared x equals 1. Dividing both sides by sine squared of x, we will have sine squared x divided by sine squared x, so 1, plus cosine squared x divided by sine squared x is cotangent squared x, equals 1 divided by sine squared x, so cosecant squared of x. So we see here cotangent squared x, so we subtract 1 from both sides. We see cotangent squared x is equal to cosecant squared x minus 1. Coming back to our original integral, we will substitute cotangent squared x for cosecant squared x minus 1 to get cotangent x times cosecant x squared minus 1. So I'm going to split both these integrals up. For our first integral, we'll have cotangent x times cosecant squared x. So we'll have cosecant squared x, cotangent x, minus cotangent x times negative 1. So I'm moving the minus to the outside, so we end up with just cotangent x. I forgot my dx there. Cotangent x dx. Alright, so now I'm going to solve for each of these integrals separately. So first, we need to solve for cosecant squared x cotangent x. So now we need to recognize the derivative of cosecant of x is negative cosecant x cotangent x. So I'm going to rewrite this integral as negative cosecant x cotangent x times negative cosecant x. And now we can recognize this is an integration by parts. So dv is going to be negative cosecant x cotangent x. So v is going to be cosecant x. Now u equals negative cosecant x. So du, since the derivative of cosecant x is cosecant x, negative cosecant x, cotangent x, the negatives cancel and give us cosecant x, cotangent x. So now we need to use the integration by parts formula, which is u dv, the integral of u dv equals uv minus v du. Alright, so we can set this equal to uv, so negative cosecant x times cosecant x is negative cosecant squared x minus the integral of v du. So we have cosecant squared x cotangent x. If we set our original integral equal to I, this integral is also equal to I. So now simplifying this, we have our equation I equals negative cosecant squared x minus I, since both these integrals are the same. So we see 2I equals negative cosecant squared x. So I equals negative 1/2 cosecant squared x. Alright, so now we need to solve for the integral of cotangent x. So cotangent is defined as cosine x divided by sine x. So in a u sub, we are going to use the denominator. So if we use u equals sine x, du equals cosine x dx, and we see cosine x dx matches with du. So this just is going to become the integral of 1 over u du. So this is the natural log of the absolute value of u, which is equal to the natural log of the absolute value of sine of x. Putting it together, the integral of cotangent cubed of x equals, back up here, I minus natural log of sine of x plus c. And I is negative 1/2, so we have negative 1/2 cosecant squared x minus natural log of sine of x plus c. So this is the final answer to our equation. If you plug this into Wolfram Alpha, you will get cosecant squared x. But if you use ChatGPT or some other LLM, you'll probably see instead of cosecant squared of x, we have cotangent squared of x. However, coming back to our Pythagorean theorem here, this relationship shows us that cotangent squared x and cosecant squared x only differ by a constant of 1. And since we have our constant here, these two results are actually the same, so that's not an issue. Alright, so thank you for watching the video. Make sure to subscribe to the channel if you want to see more content.